Hello everyone, this is Saikiran Puvvada. Welcome to the tutorial on PySpark and Pandas comparison and how do we initiate a PySpark job as part of the data science and AI lab. Today we'll be looking at what is the value addition that PySpark brings to data processing as part of the big data workloads. Let's go to the buckets to see what kind of data we might be using today. And we have two data sets. One is synthetic small data set of 100 MB, and we'll go through why did we create this small data set at later stage when we are working with pandas and PySpark. And we have a data that's around 3 GB in size. Okay, and let's uh, let's go to the data pro cluster that we have created in earlier tutorial. Here we have a cluster A1I2 with two worker nodes and one master node, and we can see the dashboard for how's the utilization, etc. CPU utilization, network bytes, disk utilization, disk operations, everything. We can submit a job. We'll go through what is a job when we kind of go through the Jupyter notebook. We have web interfaces here. We can open Jupyter Lab that we have initiated or assigned as part of the optional components when we are creating a data pro cluster. Here we can go. Uh, yeah, New tab will be opening as to show us the Jupyter notebook, and for the data we have just to show what's been part of the data. We have created a fake data with user ID, username, email, transaction amount, transaction date, and product quantity as the rows. Sorry, columns, features of the data. And this data, it's more of like as part of your 3 GB file, you have around 30 million records. As part of your, I think around 10,000 records are available as part of your 100 MB file. Okay, and we'll go through what's happening. We'll restart the kernel just in case if something left out from the earlier session. Yeah, we have Spark session to initiate to have a connection with the Spark cluster that's running as part of this. This particular Jupyter Lab instance will be running on the master node as part of the Spark cluster, and this master node helps us to communicate with the other nodes in a way to connect to the cluster, etc. If we are running this particular script as part of different VM rather than running like from Spark cluster itself, we might need to configure some additional steps so that we can connect to the cluster and make sure our transformations or data has been transported, etc. Okay, and we have some normal timing, etc. And functions as if it's more of like just to define new functions for Spark. Here we have GCS CSV path. Kind of kind of like points to the 3 GB file. Output path, this is a uh, DSAI lab output bucket, and just to store the transformation that we have done as part of this particular Jupyter notebook there, dumping in a way. And we have a pandas friendly CSV path. That's where synthetic small data comes in. We'll see what happens when we use pandas for a 3 GB file, and column amount, column quantity. And as part of to have a connection with the Spark, to communicate with it, this is the task, this is the data that's coming in, we need to transform this. That's where we need to create a session. Spark session helps us to do that. And Spark session, we might start with we might need to give a app name, and app name more is more of a metadata, just in case if your two scripts are running in parallel and both have same app name. uh, there is no chance that they might work on the same namespace. So every script will have a different session ID, so they might not overlap just based on the app name. So you guys need not to worry about this particular name should be a globally unique one. but this helps us in a way to see what are the jobs that's running in Spark cluster, etc. Will be more of a helpful for human readability. That's it. And we can start the session. Spark session has been initialized. We'll go through Spark script. First is we need to read the data from the GCP. We are using Google Cloud storage, direct links, and we basically on as part of transformation we are just calculating the average amount of total value, that's transactional average transactional value per particular user. This is where group by username aggregate f dot mean of total value alias as average total value, and after that we are showing the top 5 lines of the transformation, uh, a- and we are dumping it to the output. Let's run the script. We can see something on the something called stages. So when you give Spark script to the execution Spark execution engine, it kind of converts different components into a stage. So based on your complexity of the transformation, and if there is any additional data dependencies, the stages might be higher or lower based on the complexity. If you believe there is no data dependency, whatever we are doing is more of a row based transformations independently, then the stages might be lower. But if there is a checkpoint there where you're aggregating it, you might need to apply that particular aggregation result at a later stages. There is a dependency will be suppressed stage needs to be there, so that there is a coordination on dependency. So here at stage 5 we are applying the transformations, and can see that we, as part of Spark data frame, we have read these many rows. Yeah, this is the transformation done. We can see sample of the transformation, and we are writing the output to the GCS. There are two ways to communicate with a Spark cluster. One is Spark SQL, and the other one is more on the side of Pythonic in a way, data frame kind of interaction. Currently, we are doing data frame interaction, and just based like whatever the way you use, there is no additional improvements you could see, because this basically you are just communicating, and further optimizations are done. Even if you interact with Spark SQL or Spark Data Frame, the at later point the Spark execution engine takes care of optimizing the queries or performing the task appropriately. So you might not see any gains just because you are using SQL or just because you are using Data Frame to interact with the cluster. And yeah, we have returned the results to the GCS. Let's see what happens. Let's start with GCS pandas friendly CSV file for pandas. We can see like pandas pandas basically gets the data, transforms it, and it does in pretty faster manner, 4 seconds only, and it kind of prints the results, everything done. But the main issue with pandas is it's kind of deals with the in memory data transformation in a way, like all the data that it needs to work on should be as part of the RAM. So it limits some kind of executions in a way. What if my machine size is 16 GB, like RAM, installed RAM as part of my machine is 16 GB, but uh, in a way, like I might need to transform data of 1 TB. So that's where the issue comes in. Let's try giving the same 3 GB file to the pandas. We can see that then like kernel might shut down, because like pandas can't handle that much amount of data. and it might raise out of memory issues, etc. So this is where the PySpark comes into the picture. PySpark has that uh, fault tolerance, given it is working with multiple workers. Even if one worker fail, all the other workers kind of take care of those particular responsibilities and make sure that whatever the objective that is completed. And that fault tolerance, as well as given that option it can optimally make sure that transformation is done, given there, even though there are limited number of resources, it kind of does that transformation of data in a way, in a like maybe kind of loading whatever that's needed, and keeping the extra part as part of the cache or disk, etc. That's where like Spark comes into the picture, where it can handle big data workloads better than Pandas. In Pandas also you can do these workloads, but you need to explicitly mention it. It is not automated in a way. So some explicit tuning of Pandas might take time. It requires some amount of prof- professional experience with Pandas for you, etc. And this is how we go for PySpark. And when it comes to the terminology, like okay, what does a PySpark job mean? How does it differ as part of when you are executing as part of the Jupyter notebook, or if you submit a job to the Spark cluster? So PySpark job is basically as part of, like, when you are interacting with Jupyter Notebook, like you might have a choice to interact with it, look at the data, manipulate it, and it's kind of like interactive in nature, so that you can modify or improve the script that you are running to the optimal manner. PySpark job is more on the side of once you're done with all these fine tunings, etc., you might have a solid script or solid sequence of transformations you need to do on the job, that particular task, data transformations. Uh, the job is basically for this instance, this might be a job. This all these lines at the end might be the job. So job basically you basically submit a Python file to the cluster, and say and cluster basically executes that Python file. That's it. That is how you define job. But how does job help more than, in a better manner than when you're dealing with a Jupyter Lab notebook? Sometimes you might have options as part of GCP to as like automate that particular job at every certain time period or time frame. And also, in a way, like if there is a failure of particular job, you can, as part of the UI, you can go through the UI and see where is it failing, what are the logs, what is the status of job, etc. That will be important in case if you're debugging in case of failures, etc. That's the that's the main difference between a job and how do we interact with Jupyter notebook. There might be not a lot of improvements, but it kind of standardized the process in a way for scripts that are already finalized. And it kind of gives you better way to interact and debug the issues in case if there are any as part of that particular job. uh, this is a tutorial. Thank you for going through the tutorial. I hope this tutorial helped you to understand the need for PySpark and how it helps. Thank you.